guys, welcome to tutorial 4 and the node voltage method. And in this video we are going to use that method, the node voltage method, to calculate for V0. And we know V0 is the voltage across what? The 3 ohms. So as we've been doing, we have assigned voltages to our node. So don't forget, this is our reference, the voltage is 0. So we have a node here, V1, V2, what? V3. So the next is to write what the Kirchhoff's current law at the unknown nodes. For now, we know that V4, let's say V4 is here, is what? 0. So for now, we don't know V1, V2, and what? V3. But don't forget, for this branch here, we can connect it to what? This junction here. We can also connect this branch to that junction there. Alright, so let's see. If I have a resistor here, okay, there is a current I, which is 2 amperes, there is a resistor 2 ohms, and I have 6 volts here, I have VA here. What do you think will be the value of VA? You measure voltage across a resistor. So at this end of the resistor, there is 6 volts, but at this end, I don't know the voltage there. But I have been given the resistance to be 2 ohms, and the current through the resistor to be what? 2 amperes. So we know from Ohm's law, I is what? V over what? R. And this V is what? 6. So 6 minus VA over what resistor? 2. Okay, we are just doing some analysis here. So what is our I? Our I is given to be 2 equals 6 minus VA over what? 2. So we have 4 is equal to 6 minus VA. So what is VA? VA is 6 minus 4, which is what? 2 volts. It means I have a resistor. When current flowed through this resistor, there was a voltage drop. So voltage drop, V is equal to IR. So I have I times R giving you what? 4 volts. So there was a voltage there which is 6 volts. And that voltage produced current through this resistor. And there was a voltage drop of 4 volts across that resistor. Meaning from this the resistor has taken what? 4. Which means the voltage at the end here will be what? 2, which is 6 minus the voltage drop 4, which is the 2 volts. So in this case, let's see if I have a wire, a conductor, and there is no resistance. Let's say the resistance is 0, and I have what? A voltage at this point, let's say 6 volts, and I am saying I need the voltage at VA. What do you think will be VA? There is no resistance there. It means my 6 volts here ideally will be the same 6 volts appearing at the end here, because there is no resistor that will take part of the voltage. There won't be any voltage drop, assuming there is no resistance of that conductor. So this 6 volts will be the 6 volts across the ends of what? The conductor. So VA can also be what? 6 volts, because there won't be any losses there. So the same thing applies here. Let's see something. I have a voltage source here, and I don't have any resistor connected to what? This branch. There is no resistor on this branch, meaning the voltage here can be the same as what? The voltage at this node. I know here is my reference, it is 0 volts. There is no resistor to take part of this voltage. There won't be any voltage drop on this what? Branch. It means the 20 volts here can be the same as what? The 20 volts at this node. So now we know that node voltage, what? V1 is equal to 20 volts. In our previous videos, you realized that there was a resistor on that branch. So we can't say the voltage here is the same as the voltage here, because that resistor will take portion of that voltage, and we don't know the value of that voltage drop. So we couldn't say that the voltage here is equal to the voltage here. But in this diagram, there is no resistor here. So the voltage on this branch will be the same as the node voltage here. Good. So we know that our V1 in this diagram, our V1 is equal to what? 20 volts. So we know that V1 is equal to what? 20 volts. Our V4, which is the reference, is equal to what? 0 volts. So you can say that whenever you have a voltage source between a reference node and a non-reference node, that voltage is equal to what? The voltage at the non-reference node. When you have a voltage between a reference and a non-reference node without any resistor, that voltage is equal to what? The voltage at the non-reference node. So now we know V1. Alright, so it means we are not going to write KCL at V1, because I said we write KCL at the non-reference node or the unknown nodes. Now we know this one, so we are going to write KCL at what? V2 and V3. So let's assign our currents. So let's say there is a current here, I1, there is a current here, I2, there is a current here, what? I3. There is a current on this branch already given. On this branch there is a current, but on this branch we can assign a current. Let's say I what? I4. So we are going to write KCL at node 2 and node 3. So let's start with node 2. So KCL at node 2. KCL at node 2. So node 2, how many branches? We have 3. So I1 is entering plus 1 is also entering is equal to what? I2, which is leaving. So let's express I1. I1 is what? V1 minus, so I have V1 minus what? V2 over resistor 4 minus, let's bring the I2 here, or let's say plus 1 is equal to I2. I2 is V2 minus V3 over what? Over resistor what? 2. So from here we can do what? Find our LCM and multiply through. Don't forget our V1 is what? 20. So from here we can substitute our value. We have 20 minus V2 over 4 plus 1 is equal to V2 minus V3 over what? 2. Our LCM is 4. So multiply here by 4. I have 20 minus V2 plus this one by 4. I have 4 is equal to 2V2 minus 2 what? V3. So let's group our like terms. What do we have? We have 3V2 minus 2V3 is equal to what? 24. As our first equation. I just group the like terms. I send the V2 to the other side. So 3V2 minus 2V3 is equal to what? 24. So the next thing is to write KCL at this node. So KCL at node 3. So KCL at node 3. So what do we have? How many branches are making up that node? We have 1, 2, 3, 4. 4 branches. So we can write our KCL here. Which of the current is entering? I2 is entering. I4 is entering. But this 2 amperes is what? Leaving that node. I3 is also what? Leaving. So entering is what? We have I2 plus I4. Those are the currents entering. The leaving ones are what? 2 and what? I3 is equal to 2 plus what? I3. Very simple. So now let's express the current. What is I2? V2 minus what? V3. So V2 minus V3 over 2 plus what is I4? Now look at I4. I4 is starting from where? V1, moving all the way to where? V3. So I have V1 minus V3 over resistor 6 is equal to 2 plus I3. I3 is what? V3 minus our reference V4. So we have V3 minus the V4, which is 0, over resistor what? 3. Very simple. So don't forget our V1 is what? 20 volts. So we have to substitute that 20 volts there. So we have V2 minus V3 over 2 plus 20 minus V3 over 6 is equal to 2 plus V3 over what? 3. LCM is what? 6. So let's multiply through by 6. So I have 3V2 minus 3V3 plus 20 minus V3 is equal to what? 12 plus 2 what? V3. We just multiply through by 6. So 6 here, 6 here, 6 here, 6 here is giving us this. Let's group our like terms. I have V2. So 3 what? V2. What about the V3? I have minus 3v3 minus v3. I'm bringing this one there, minus 2v3, giving us minus 6 v3 is equal to what? 12 minus 20. And that one is minus what? 8. Alright, so we have equation 1, equation 2. How many variables? We have 2, v2 and v3 in both of the equations. So let's find our variables. So I'm using the calculator to punch mine. So I have 3 minus 2, 24. I have what? 3 minus 6 and what? Minus 8. So my V2 is what? 13.333 volts, and my V3 is what? 8 volts. So I have my load voltage is V2 to be that, my V3 to be what? 8 volts, and my V1 to be what? 20 volts. But the question is asking us to find what? V0. That's the voltage across the 3. So the voltage across the 3 is the same as what? The V3 minus the V4. That's the voltage across the 3. We knew that its current is what? The current through the 3 is what? I3. So this is the current through what? The I3. So it means the numerator is what? Its voltage. The denominator here is what? Its resistor value. So the V0 is the voltage across the 3, and that is the same as V3. So in this diagram, our V0 is what? Is equal to V3, which is equal to what? 8 volts. So we've used the node voltage method to calculate the voltage across a resistor. So our point in this tutorial is for you to know what happens when you have a voltage between a reference and what? A non-reference. Not forgetting that that voltage will be the same as the voltage at the non-reference node. Don't forget that one. Thank you very much for watching this tutorial video.